Converting units of measurement. Why convert units? Many different units are used in science, mathematics, engineering, and finance. The units need to be converted so they are understood by different organizations. For example, what if you travel from the USA to Mexico and need to fill up your car with gasoline and you need to know how much it would cost in the USA? The sign on the gas pump advertises a price of $22 per liter. The dollar represents Mexican pesos, not American dollars. L represents liters. Those are not units used in the USA, which are American dollars and gallons. Fortunately, you at least know that the Mexican peso is abbreviated the same as the American dollar, but not equivalent to it. For clarity, we'll use the currency code MXN for the Mexican peso and USD for American dollar. Unit conversion. You need to convert the units from the Mexican gas station to the USA units to see how much the gas would cost in the USA. Unit conversion is the process of using ratios equal to 1 and conversion factors to convert a measurement to a different unit, Mexican pesos and liters to American dollar and gallons. Doing so doesn't change the value, but new units are obtained. Two different conversion factors are required and are shown below. 1 liter equals 0.26 gallons, and 20.3 Mexican pesos is equal to $1 US. Conversion factors are written as ratios, as shown here. You have to be careful to put the right values in the numerator and denominator so they cancel. So we notice that 1 liter is equal to 0.26 gallons, and it's written in this manner here. Notice the liters are over top of the gallons. Our second one is that 20.3 Mexican pesos is equivalent to $1 US. And again, this is written in this fashion here. Notice again that we put the Mexican pesos over top of the US dollars. Write the conversion factors starting with the original units and finishing with the desired units. Leave a space between them to fill in the conversion factors that will cancel out the original units, leaving only the final units. Write the original units with their values and the desired units. So we start with the original units of price of gas per liter in Mexico, and we want to end up, our desired ending point is going to be the equivalent gas price in gallons in the USA. So next what I do is in the box, I write the USA equivalent. 1 liter is equal to 0.26 gallons. I multiply by 1 the ratio of liters to gallons. The liter per gallon conversion factor was written so that the liters would cancel out from the original units. Notice that I have the liters canceling out, just like you would with regular math. Next, I put in the ratio of US dollars to Mexican pesos, and again, I multiply by 1. So you'll see there's a 1 on the top, and I cancel out the units. Over here, I cancel out this Mexican peso unit with this Mexican peso unit over here. The only units that do not cancel are highlighted in yellow. I finished the problem by multiplying the numbers that were in the conversion factor. So across the top, I multiply 20.3 times 1 times 1. Along the bottom, I write 1 times 26 hundredths times 20 and 3/10, and I find the quotient between the two, and that results in $4.19 per gallon. The gasoline cost of 20.3 pesos per liter in Mexico is equivalent to $4.19 per gallon in the USA. And this is what it looks like as it's written out. We write the original units with their values and the desired units. So on the far left side in that first square, we write down that 22 Mexican pesos per liter. That was the cost of gasoline in Mexico. On the far right square, we want to find out, our goal is to relate that to US dollars. So how much would that cost in USA dollars per gallon? In the second square, I'm going to write the conversion factor for liters to gallons. Remember that 1 liter is equivalent to 0.26 gallons. I cancel out the units that were identical in the numerator and in the denominator, in this case the 1 liter, by drawing a red line through those. The liter per gallon conversion factor was written so that the liters would cancel out from the original units. I placed 1 liter here in the denominator, and I placed the other one in the numerator. It was convenient to place it that way so they cancel. Now let's turn our attention to the third square. Here I write the US dollar conversion factor, so 1 US dollar is equivalent to 20.3 Mexican pesos, and I cancel out the MXN units. So if I look on the top square here, I canceled out this MXN unit with the denominator down here, the MXN units. The only units that do not cancel are now highlighted in yellow. So what's left? US dollars per gallon. That's what we were going for. Now we can finish the problem by multiplying the numbers that were in the conversion factors. So across the top, I multiply 22 times 1 times 1. And across the bottom, I multiply 1 times 0.26 times 20.3. And the end result is going to be $4.17. So the gasoline that costs 22 pesos per liter in Mexico is equivalent to $4.17 per gallon in the USA. Converting units. Example 1. At top speed, a cheetah can run with a velocity of 33.5 meters per second. How fast is this in miles per hour? The information that is needed to create these conversion factors are the following. 60 seconds is equal to 1 minute. Now this is the neat part. The fraction 60 seconds to 1 minute is equal to 1 because they're equivalent, and anything over itself is equal to 1. So when you multiply by that fraction, you are indeed multiplying by 1. The same thing for 60 minutes is equal to 1 hour. When we write it in fractional form, since they're equal, that fraction is equal to 1. 1 mile is equal to 1,609 meters. We found this out by looking it up on the web. So the fraction, or the ratio, 1 mile to 1,609 meters is also equal to 1. So when we multiply by these fractions, we're indeed multiplying by 1 and we're not changing the value, even though the units are different. Let's go to the next slide. Since each conversion factor is equal to 1, we're going to start with meters per second and we want to finish with miles per hour to ensure the conversion factors are set up to cancel out all the intermediate units. So we set it up in such a way so that the units cancel. So we multiply all the numbers of the factor coefficients to find the cheetah's velocity in miles per hour. So when I set this up, I start with 33.5 meters per second. I set up all my conversions, so 60 seconds per minute, that's equal to 1. 60 minutes in an hour, that's equal to 1. 1 mile is equal to 1,609 meters, and I set up in such a way where everything cancels out. And the only thing I'm left with is 1 mile up here, so I got miles per hour. And doing the arithmetic, we find out that a cheetah can run 74.95 miles per hour.
Sample problem number 1. Let's consider an iron bar that is 1 centimeter long, 1 centimeter wide, and 1 centimeter thick. And it has a linear mass density of 7.86 grams per centimeter. We want to find its linear density in terms of ounces and inches. So our goal here is to convert grams per centimeter to ounces per inch. So first of all, we need to find a conversion factor. And we go to the web and we find out that 1 gram is equal to 0.0353 ounces. And I write that as a fraction. Okay, so right here I have grams over ounces. And remember, this fraction is equal to 1, okay, because they're equal to each other. I also now go down here to, off the web, I find a centimeter to inch conversion. So 1 centimeter is equal to 0.394 inches. And again, I write it as a fraction, 1 centimeter over 0.394 inches. That fraction is also equal to 1. So keep in mind down here, these fractions are 1. Okay, so really what I'm doing is I'm multiplying by 1 to get an equivalent ratio. Now, I took this ratio and I wrote it in terms of ounces to grams because I wanted these grams to cancel out. So I'm going to cancel this gram here with grams here. And over here, I cancel centimeters with centimeters. And what I'm left with is ounces per inch. That's what I want, ounces per inch. So when I do the arithmetic, I take 7.83 times 0.0353. And on the bottom, I take 1 times 1 times 0.394. And when I work everything out, I'm going to get the final answer of 0.702 ounces per inch.